So here we are looking at a common textbook exercise in analytic geometry. This type of exercises, they come in different variations, but if we break them down, the situation is essentially as follows. You're given 4 points A, B, C, D in the three-dimensional space. And the question we are asking is, what type of quadrilateral A, B, C, D do these points form? Now, before we solve this specific exercise, let's talk about some common misconceptions in this context. The first misconception is that 4 points A, B, C, D form a quadrilateral. Now, this is not necessarily the case in the three-dimensional space. By definition, 4 points form a quadrilateral if they lie on the same plane. Now, in this image here, well, A, B, C, D, they lie in the same plane, and therefore this would be a quadrilateral. But this doesn't have to be the case in the three-dimensional space, because we could move D up here, for instance, and in this case, A, B, C, D wouldn't lie on the same plane anymore, and therefore A, B, C, D wouldn't be a quadrilateral. There's still a name for that. In mathematics, we call this a skew quadrilateral, but it's not a quadrilateral. Now, that's the first misconception. The second misconception is very closely related to this first one, and it is that if 4 sides have the same length, then A, B, C, D is either a square or a rhomboid. Now, it's true that in a square or a rhomboid, all 4 sides have the same length. But in the three-dimensional space, there are different shapes that also have 4 sides with the same length. So if you look at instance at these two images, then on the left, well, we have a square. Here, all the 4 points lie on the same plane, and all 4 sides have the same length. But on the image on the right, here we have a skew square. Again, all 4 sides have the same length, but we don't have a square because this is a skew square. So these are common misconceptions when it comes to this type of problems, and it's important to look out for those and be aware of those. Now that we talked about some common misconceptions, let's have a look at this specific exercise here. So the exercise says, parallelograms, rhomboids, rectangles, and squares have the property that their diagonals bisect each other. In other words, the midpoints of the diagonals coincide. Prove that the quadrilateral ABCD has this property. Which of the types of quadrilateral given is it? Give reasons. So we need to determine the type of quadrilateral, and in this exercise, we are already given a hint how we can approach this type of exercises. The hint is hidden here. It says that we should, it points out a fact about the diagonals. It says that the diagonals bisect each other. So first thing I want to do is, let's talk about the diagonals and why they are so important in this case, and what the diagonals tell us. Now, before, when we talked about some common misconceptions, we said that one misconception is that 4 points in the three-dimensional space don't necessarily form a quadrilateral. So, right, if we have a point up here and we call it D1, then A, B, C, D1 don't lie in the same plane and therefore don't form a quadrilateral. Now, how can we figure out whether A, B, C, D1 lie in the same plane? Once you know a bit more about analytic geometry, you will notice there are different ways how to figure this out. One way is to look at the diagonals. So let's quickly draw the diagonals. That's the first one here. And this one would be the second one. And what we can see now is that if they don't lie on the same plane here, these points, then the diagonals won't intersect, right? There's no point of intersection between these two lines. Now, in case the points would lie on the same plane, so if we have a point down here, D2, that is on the same plane, and we also draw the diagonal here, then these two diagonals here, they would intersect in a point of intersection here, right? Now, therefore, diagonals are important, and they tell us whether the 4 points lie on the same plane and form a quadrilateral. So if we can figure out whether they intersect, then we know that the 4 points form a quadrilateral. And if they bisect each other, in other words, the midpoints coincide, then that's even a stronger criteria, because then we know that they form a quadrilateral, and they form actually a special type of quadrilateral, because there are only 4 quadrilaterals where the diagonals bisect each other. And these are the only 4 types, so a square, rectangle, parallelogram, and rhomboid. You can check this on your own, so just draw 2 diagonals that bisect each other, and you will notice that the only 4 shapes that will come out from this will be either a square, a rectangle, a parallelogram, or a rhomboid. So this means that we need to look at the diagonals, and we need to figure out the midpoints of the diagonals. So if they coincide, then this tells us already a lot. So let's do this. First of all, let's look at the midpoints of the diagonals, and we try to determine those. We have 2 diagonals. We have the diagonal from A to C and the one from B to D. So let's first determine the midpoint from the diagonal AC. Let's call this AC, and we have the midpoint formula for that. So it's just the average of the x-coordinates, so 0 plus 1 divided by 2, then the average of the y-coordinates, 2 plus minus 2 divided by 2, and for the z-coordinate it's 1 plus 6 divided by 2, and if we calculate that, then we get 1/2. Here we get 0, and for the z-coordinate we get 7 divided by 2, so 3.5. So that's the midpoint of the diagonal AC. We can just do the same for the diagonal BD, which I already did, and we will get the midpoint 0, 1/2, 0, 3.5, which is the same. So here we figured out that the midpoints of these 2 diagonals coincide. Let's repeat again what this means. This means, first of all, that the points A, B, C, D form a quadrilateral, and what it also tells us is that they form one of those 4 quadrilaterals here. All right, so now we just need to figure out which one of those 4 it is. And for this, well, let's see what else we can say, or what distinguishes these quadrilaterals. So one thing is we can look at the side lengths, right? So we see that for the square and the rhomboid, all 4 sides have the same length. That's not the case for the rectangle and the parallelogram. So let's then figure out the side length of our quadrilateral in a second step. So we want to determine the side length, and we need to determine all 4. Let's do this for 1 here, for the side length AB. And that's just, well, the difference in the x direction. That's from 0 to -1, it's -1. So -1 squared plus difference in y direction, 2 -1, that's -3 squared, plus the difference in z direction, so it's from 1 to 3, 2, so plus 2 squared, and then the square root of that, and that's 1 plus 9 plus 4, so square root of 14. Means the side length of AB is square root of 14. We calculate the other side lengths, which I already did here in this case, and we will notice that all 4 sides have the length square root of 14. So this means, from this, we can conclude that it is either a square or a rhomboid here. Now, which one is it? For this, we need a second criteria, and when we look at those 2 again, right, at the rhomboid and the square, we see that there's one thing again that distinguishes those 2, and that's the length of the diagonals, right? For the square, the diagonals have the same length. In the rhomboid, the diagonals don't have the same length. So let's figure out the length of the diagonals. In a last step, we do this down here. So we need the length of the diagonal from A to C and from B to D. Let's do A to C together. So here the length AC, again we need our length formula. So the difference in x direction it's 1 squared plus in y direction it's 2 minus 2. That's a difference of minus 4 squared. And in z direction we go from 1 to 6. That's a difference of 5. So plus 5 squared. And the square root of that. We count that together. So 1 plus 16 plus 25, which gives us 42, square root of that. So that's the length of the diagonal AC, square root of 42. Figure out the length of the second diagonal, which I already did here, and we will get that the second diagonal has a length of square root of 14. So this means the two diagonals don't have the same length, different lengths, and so we know that we have a rhomboid. Final answer, the quadrilateral ABCD forms a rhomboid. All right, let's summarize this again. First of all, we wanted to know whether it is a quadrilateral and whether it is one of those 4 types of quadrilaterals. We figured this out by looking at the midpoints of the diagonals. If they coincide, we know that they are that the shape forms a quadrilateral and that it's one of those 4 types. Then we wanted to know whether it's a square or a rhomboid or a rectangle or a parallelogram, and we figured this out by looking at the length of the sides as well as the length of the diagonals.